Hello everyone, welcome to the new video of Pros and Experts. The next question is, determine the Fourier series representation for x of t equal to 2 sine 2 pi t minus 3 plus sine 6 pi t. Alright, the first thing I want to tell you is, for these kind of questions where you are asked to find out the Fourier series for signals like sinusoidals or cosines or complex exponentials, what you have to do is use the method of inspection. That's the best thing you can do for these questions. Okay, so before starting the solution, let me find out the angular frequency of the signal. You're given x of t equal to 2 sine 2 pi t minus 3 plus sine 6 pi t. Okay, let us find out the angular frequency of the signal. Angular frequency of the signal, why I am finding the angular frequency? Because you need to know the okay, I will tell you. You need to know the Fourier series representation of a time domain signal. The Fourier series representation of a time domain signal, that is given by x of t equal to sigma over k equal to minus infinity to plus infinity cn e raised to j k omega 0 t. Okay, so every continuous time periodic signal, like our question signal, can be expressed like this: x of t equal to sigma cn e raised to cn e raised to jk plus jk omega 0 t. Okay, it is plus. Now you can see omega 0 here, which is nothing but the angular frequency of the given signal. Whatever signal we are representing using the Fourier series, the angular frequency of that signal. Okay, so that's why I'm finding the angular frequency of our given x of t. How will you find the angular frequency? If you remember, it is nothing but HCF of the numerator in the argument, that is 2 pi comma 6 pi divided by LCM of denominator. Denominator is 1. Okay, so that is given by 2 pi. Okay, LCM of 2 pi and 6 pi is 2 pi. So omega 0 equal to 2 pi. So save it for the later purposes. Okay, now so you understand what is Fourier series representation of a signal, and you have the given signal question and its angular frequency. Now my aim is method of inspection. The aim is represent the question signal, which is a sinusoid or a cosine, in the form of this equation, Fourier series equation. Okay, so whatever trigonometric knowledge you have, you apply it. Therefore, I can rewrite my question x of t as 2 into, what is sine 2 pi t minus 3? Sine 2 pi t minus 3 is nothing but 1 by 2j into e raised to j 2 pi t minus 3 minus e raised to minus j 2 pi t minus 3. That's it. Okay, that's sine 2 pi t minus 3. It's not over, plus 1 by 2j. Again you have a sine 6 pi t there, right? Sine 6 pi t. So sine 6 pi t is e raised to j 6 pi t minus e raised to minus j 6 pi t divided by 2j. That's there. Okay, so that's the question. So I have rewritten my question in terms of complex exponential. Okay, now let me expand this equation. 2 and 2 get cancelled, so this is 1 by j into, you can split e raised to j 2 pi t minus 3 as e raised to j 2 pi t into e raised to minus j3. Okay, minus 1 by j into, again I can split e raised to minus j 2 pi t minus 3 into e raised to minus j 2 pi t into e raised to plus j3. Okay, that's the expansion of the first bracket. Plus, now I can expand the second bracket. that is 1 by 2j e raised to j 6 by t minus 1 by 2j e raised to minus j 6 by t. Okay, a little more simple rearrangements will give me 1 by j e raised to minus j3 into e raised to j 2 pi t, okay, minus 1 by j e raised to j3 into e raised to j 2 pi into minus 1 into t. I can write it like this, okay, e raised to minus j 2 pi t is e raised to j 2 pi into minus 1 t for some specific reasons, okay, plus 1 by 2j into e raised to j 2 pi into 3t, okay, e raised to j 2 pi into 3t, because you know e raised to j 6 pi t is e raised to j 2 pi into 3 into t, same, okay. Similarly, minus 1 by 2j into e raised to j 2 pi into minus 3t, okay, that must be clear. E raised to minus j 6 pi t is e raised to j 2 pi into minus 3 into t, okay. So I have rewritten my expression like this, okay. Let me give this as equation number 1, okay. Now listen very carefully, be very attentive. What I'm going to do is I am going to expand the Fourier series expression, this expression given omega 0 equal to 2 pi. So I'm going to substitute omega 0 equal to 2 pi and going to expand this expression. So that implies x of t is equal to sigma over k equal to minus infinity to plus infinity Cn into e raised to jk into what is omega 0? Omega 0 equal to 2 pi. So jk into 2 pi into t. Okay, that is my equation number 2. That is my equation number 2. Now let us start the method of inspection. This is method of inspection. You examine equation number 1 and equation number 2. Okay, equation number 2 has an exponential, complex exponential signal scaled by a scalar value, right? Scaled by a value Cn, right? This is a signal. This is not a signal. Okay. Now, examine equation number 1. Every term in equation number 1, right? Every term in equation number 1 has a signal, complex exponential signal scaled by a value. A scalar value, maybe complex, no problem, but it is a scalar value, okay. This term also has a complex exponential signal. This is a signal part because there is a t in it, okay. This is a signal and scaled by a constant. This is a signal scaled by a constant, signal and scaled by a constant, okay. So whatever be the coefficient of this signal, that means this thing will be Cn, right? That's what we get by inspecting these two equations. So whatever be the coefficient of signal, that means this thing becomes my Fourier series coefficient Cn, okay. And the value of k, here there's a k, right? K, okay. That k can be easily found out by inspecting corresponding terms, right? Okay, so let me make it clear for you. So I can write with some intuition from equation number 1 that x of t equal to the first term we have this factor, this function, right? What will be this function? I can write it as c c1, right? Because you know omega 0 is 2 pi, right? Omega 0 is 2 pi. So if this is omega 0, then what is k? By comparing these two terms, what is k? K should be 1, right? Only if you put k equal to 1 here, you will get e raised to j 2 pi t here, right? Okay, so k is actually 1. For avoiding confusion, let me change it as ck. Okay, ck, because here it is k, so ck should be here. Okay. So by combining or by inspecting these two terms, we can easily come to the conclusion that k equal to 1. Okay, so I can write it as k equal to 1. So this is C1. Okay, so C1 into e raised to j 2 pi t. Okay, plus what is the next term? Next term has e raised to j 2 pi into minus 1t. You compare it with e raised to j k 2 pi t. So what is k? K is simply minus 1. Easily minus 1. Okay, and what is c of minus 1? If k is minus 1, you call it c minus 1, right? C minus 1. What is c minus 1? Whatever be the coefficient of this signal, that is minus 1 by j into e raised to j3, that is c minus 1. Okay, so I can write it as c minus 1 e raised to j2 pi minus 1 into t, because k is minus 1 there. Okay, plus now let us see the third term, this term. Here e raised to j2 pi 3t. Okay, compare it with e raised to j k 2 pi t. What is k? K is 3. Okay, so this value is c3. Okay, so c3 into e raised to j 2 pi 3 into t. Okay, and the last term is it's having the signal e raised to j2 pi minus 3 into t. Okay, e raised to j2 pi minus 3t. And if you compare with e raised to jk2 pi t, what is k? K is nothing but minus 3. Okay, so the coefficient of this signal, that is minus 1 by 2j, is c minus 3. So I can write it as c minus 3 e raised to j2 pi minus 3 into t. Okay, so everything is over. Now we can write it as c1 is equal to, c1 is nothing but 1 by j e raised to minus j3. Okay, c2 is equal to, c minus 1 is equal to, what is c minus 1? This thing, minus 1 by j, don't forget the minus sign, minus 1 by j e raised to plus j3. Okay, then what is c3? c3 equal to, c3 is the coefficient of this signal, that means 1 by 2j plus 1 by 2j, and finally c minus 3 is equal to this thing. Again, do not forget minus sign, that is minus 1 by 2j. Okay, so that's the final answer. So remember, in problems like this where sinusoidals or cosines or e raised to j exponential, complex exponential comes, and you are asked to find the Fourier series, not Fourier transform, Fourier series, then definitely do by method of inspection. Okay, method of inspection means what you have to inspect is this term and this equation and this equation. Actually, this equation is the rearranged version of our sine signal. Okay, these two equations are to be matched. Okay, you will get the answer. So that's the end of this question. Okay, the next question is, show that the spectrum of the sample signal is the infinite sum of shifted replicas of the spectrum of the original signal. So they are asking us to prove the sampling theorem. What is sampling theorem? Sampling theorem is actually one of the most beautiful theorems in signals and systems, which is applied in various areas in signal processing and electronics and communication, like analog communication, digital communication, etc. So sampling theorem says that a signal can be sampled, not alone sampled, and reconstructed. I think we have discussed this in some previous problems. So a signal can be sampled and reconstructed faithfully if and only if the signal is sampled at a sampling frequency which is greater than at least equal to 2 times the maximum frequency of the message signal. So this is what sampling theorem says. And the output frequency spectrum of a sampled signal is actually it's given in the question, actually an infinite sum of the shifted replicas of the spectrum of the original signal. Okay, so what we know is if this is the message signal spectrum, not signal in time domain but spectrum. Okay, let this be the spectrum of the message signal. Then after sampling, what we get is infinite sum of shifted replicas in both sides. Okay, this is x del of f, where x del of f is the sampled signal spectrum. This is message signal spectrum, this is sampled signal spectrum. So this contains infinite replicas of our message signal spectrum. This is what we got to prove mathematically. Okay, let's do that. So before starting the solution, let me say that how is sampled signal formed? Sampled signal is formed from a message signal. Let m of t be your message signal. Okay, then sampled signal is obtained. This m of t is a message signal. Then sampled signal, let me call it as x del of t. This is obtained by simply multiplying m of t with an impulse train, a periodic impulse train p of t. You know what impulse train is? This is impulse train. Just as the name suggests, as a train of impulses. Okay, each impulse t seconds apart. This time domain. Okay, and this is my p of t. All right. So the sampled signal is nothing but the message signal multiplied in time domain with p of t, where p of t is the impulse train. Okay. I can even pictorially represent it if m of t is any analog signal, continuous time signal, and if this is the impulse train p of t, this is m of t, and this is p of t. If you multiply these two, what we get is the same impulse train, but whose envelope will be the message signal. Okay, this is nothing but sampled signal, right? This is x del of t. Okay, now let us move in its frequency domain. What is the equivalent in frequency domain of multiplication in time domain? This is multiplication in time domain. Okay, what is its equivalence in frequency domain? It is convolution. Okay, this inverse convolution theory or multiplication theory of Fourier transform. So we can write the spectrum as x del of f is equal to, where x del of f is the Fourier spectrum of sampled signal, right? Okay, so that will be equal to m of f convolved with p of f. Okay, m of f convolved with p of f. Now care should be taken that p of f or p of t is a periodic signal, but we are going to take the Fourier transform of a periodic signal, right? Is that possible? Finding the Fourier transform of a periodic signal. You have studied that periodic signal is analyzed by Fourier series because it is periodic, but periodic signal can be assessed with Fourier transform also. That is actually not included in most of the university's bachelor syllabus. It is a slightly advanced topic, so just take care that if I can simply tell you our p of t is equal to sigma del of t minus nts, n equal to minus infinity to plus infinity del of t minus nts. Is that right? It should be right, because if n equal to 0, you will get del of t. That means this impulse. Okay, if n equal to 1, it will be del of t minus ts. That means the next one. Okay, if n equal to 2, you will get the next one. And similarly in negative n's, n equal to minus 1 means you will get this one, n equal to minus 2 means this one. So finding the sigma of the signal will give you the entire p of t. Okay, so I can broadly represent P of t is equal to sigma n of n equal to minus infinity infinity del of t minus nts. Fine. Now you have to take care that you just learn this. P of f is equal to, right? P of f is equal to sigma cn into del of f minus nfs. Okay, this is how you find the Fourier transform of periodic signal. Normally Fourier transform is for non-periodic signal, but we can find Fourier transform of periodic signal by this format. Okay, so P of f is equal to sigma n equal to minus infinity cn del of f minus nfs. What is cn? Cn is actually the Fourier series coefficient of impulse. Cn is actually the Fourier series coefficient of impulse, which is given by 1 by ts. Okay, and 1 by ts is the sampling interval. You can see it here, right? Ts is the sampling interval. And what is 1 by ts? 1 by ts will give you the sampling frequency. Okay, so this is fs also. So I can write it as x del of f is equal to m of f convolution. What is p of f? P of f is 1 by ts, or I can take this ts or whatever fs, whatever it is outside the sigma. So fs into sigma over n cn. Cn is fs. Okay, del of f minus nfs. Okay, you might be understanding what I've done here. I have done nothing but I have found the Fourier transform of a periodic signal. That is nothing but impulses, shifted impulses scaled by its Fourier series coefficient. Okay, that is Cn, right? But Cn, we know the impulse, the Fourier series coefficient of impulse train will be Cn equal to 1 by ts. You can see it here, 1 by ts, but 1 by ts is fs. Actually, this will be how you got 1 by ts will be described in the coming sessions. I think there will be a problem like that. Then it will be clear to you. So for the time being, you learn this. Okay, right. Now as a result of this, I got this equation like this. Okay, now you know the convolution property of impulse. I can write it somewhere here. What is x of t minus a convolution del of t minus b? It is x of t minus a minus b. Okay, del of t is actually an identity element with respect to convolution. So it is x of t minus a minus b. So similarly, I can write it as fs into, fs can be taken outside, it's a constant. So fs into sigma over n equal to minus infinity to plus infinity m of f minus nfs. Okay. Okay, so this is the spectrum of the sampled signal. Okay, now why don't we just try to plot this? I can plot this as before plotting, we have to assume that our message signal will be having a Fourier spectrum like this. This is a band limited signal. Fm is the maximum frequency component. Okay, this is m of f. Okay, centered at 0. Now how can you realize this equation? This is the expression for the Fourier spectrum, Fourier transform of sampled signal. How will it work? How can we plot it? Just put n equal to 0. This is a sigma equation, n equal to 0. What you will get? It will be fs into m of f. So at n equal to 0, you will get the message signal Fourier spectrum as such, but scaled by fs. Okay, so this is fm, this is minus fm, and centered at 0. Okay, that's for n equal to 0. You can write it n equal to 0. Now what is for n equal to 1? For n equal to 1, this equation becomes x del of f is equal to fs into m of f minus fs. What is m of f minus fs? M of f minus fs. It is nothing but shifting, right? If m of t minus ts, we shifted ts units to the right. Okay, similarly, if it's a function of f, m of f minus fs is shifting the same spectrum, shifting the same function fs units to the right. So I can draw the signal somewhere here if this is fs. Okay, now this is for n equal to 1. What is for n equal to 2? N equal to 2 means f sigma m into m of f minus 2fs. So shifting 2 units, this spectrum, original spectrum, is shifted to 2 units. Okay, so here it is 2fs. And similarly for n equal to minus 1, we will get negative values also, minus fs minus 2fs. Okay, and this continues to infinity. So this is the spectrum of sampled signal. So that's what the question says. Show that the spectrum of the sampled signal is the infinite sum of shifted replicas, right? Infinite sum of shifted replicas are there. Okay, so that's the end of the answer. Okay, the next question is, evaluate the Fourier transform of x of t equal to d by dt of t e raised to minus 2t sine t u of t. Okay, so this is a bit confusing question. The question is very simple. You have to apply all of the properties of Fourier transform, most of it, but you have to be very concentrating while doing this problem. There's a very good chance to make mistakes. All you need is be thorough with the Fourier transform properties. Okay, let us start the solution. Okay, first of all, there's a sine t in this signal. Okay, sine t. So we know what sine t is. So I can write sine of t is equal to, we know what is sine of t. It is 1 by 2j e raised to plus jt minus 1 by 2j e raised to minus jt. Okay, this is sine t expressed in terms of complex exponential. Okay, and now question has e raised to minus 2t into sine t of t. So I am multiplying the signal with e raised to minus 2t sine t. Okay, e raised to minus 2t into u of t. You can write u of t here also, nothing wrong. So what happens is you multiply 1 by 2j into e raised to minus 2t e raised to jt minus 1 by 2j into e raised to minus 2t into e raised to minus jt. Nothing, just I have taken e raised to minus 2t and multiplied with both the terms. Okay, so you got this. And now I can just simplify it as 1 by 2j into e raised to, I can write as e raised to minus of 2 minus j into t. Okay, minus 1 by 2j into e raised to minus of 2 plus j into t. That must be correct. Okay, so I can take this 1 by 2j outside also. 1 by 2j into e raised to minus of 2 minus j into t minus 1 by 2j is already taken out. Okay, minus e raised to minus of 2 plus j into t. So that is e raised to minus e raised to minus 2t sine t u of t. Okay, now we start taking the Fourier transform. Okay, now take Fourier transform. So Fourier transform of e raised to minus 2t sine t u of t is equal to 1 by 2j is a constant. We can take it outside because of linearity property. So 1 by 2j into Fourier transform of e raised to minus of 2 minus j into t. Okay, minus again Fourier transform of e raised to minus of 2 plus j into t. Okay, so I can write the reason as because of linearity property. Okay, now I can simplify it as 1 by 2j into, what is Fourier transform of e raised to minus 2 minus j into t? You always know, the Fourier transform of e raised to minus at u of t is nothing but 1 by a plus j omega. Okay, so e raised to minus at u of t for the transform will give you 1 by a plus j omega. So applying that relation here, this is actually e raised to minus of at u of t, where a is 2 minus j. Okay, so I can write it as, so Fourier transform is 1 by 2 minus j plus j omega, right? 1 by 2 minus j is actually a, right? 2 minus j is a, so a plus j omega, similar. So 1 by 2 minus j plus j omega minus, what is the Fourier transform of this term? It is similar also, this is also right, like e raised to minus at u of t. So I can write as 1 by 2 plus j omega. Okay, that's the Fourier transform of the second term. Okay, now this is 1 by 2j into 1 by let me take the j terms common, so 2 plus j into omega minus 1, right? Minus of, here also 1 by 2 plus j omega into 2 plus j into omega plus 1. Fine. So this is the Fourier transform of e raised to minus 2t sin t of t. But in the question it is given as t into e raised to minus 2t into sin t of t and differential of it. Okay. Now I have to add a t here, right? I have to find out t e raised to minus 2t sin t of t. For that, let us see what we can do. What is the Fourier transform of, I can write in another color, what is the Fourier transform of minus j t x of t? If x of omega is the Fourier transform of x of t, what is the Fourier transform of minus j into t into x of t? It is nothing but d by d omega of x of omega. Okay, it is frequency differentiation property of Fourier transform. So similarly I can write Fourier transform of minus j t x of t, or minus j into t into, instead of x of t it is e raised to minus 2t sin t of t. Okay, what you get is 1 by 2j into d by d omega of the whole thing, 1 by 2 plus j into omega minus 1 minus 1 by 2 plus j into omega plus 1. This frequency differentiation property. Okay, now let us attempt to differentiate it. 1 by 2j into, what is the differential of the first term? D by d omega of 1 by 2 plus j omega minus 1 will give you minus 1 by 2 plus j into omega minus 1 the whole square, right? The whole square into the differential of this denominator term will be it is differentiating with respect to omega, so it will give you j, so multiplied by j. Okay, that is the first term, minus d by d omega of our second term. Again it is a similar term, so we can write it as minus 1 by 2 plus j into omega plus 1 the whole square into j. Okay, now I can take j and j outside the bracket. Okay, j and j outside the bracket, and it can be cancelled with this j, right? So this is equal to 1 by 2 into minus 1 by 2 plus j into omega minus 1 the whole square. Here is a plus 1 by 2 plus j into omega plus 1 the whole square. Okay, So this is the Fourier transform of not of t into e raised to minus 2t sin t of t, but the Fourier transform of minus j into t into e raised to minus 2t sin t of t. But we don't need this j here. So according to linearity property, we can take this j to the denominator of this RHS. Okay. Therefore, Fourier transform of t e raised to minus 2t sin t of t is equal to minus 1 by 2j. I'm taking minus j to the denominator, so minus j to the denominator into minus 1 by 2 plus j into omega minus 1 the whole square plus 1 by 2 plus j into omega plus 1 the whole square. Okay. Now I can convert this 1 by j into numerator. It will become minus j, right? 1 by j is actually equal to minus j. So performing that, I will get this as plus j by 2 into, right, plus j by 2 into minus 1 by 2 plus j into omega minus 1 the whole square plus 1 by 2 plus j into omega plus 1 the whole square. Okay, this is a Fourier transform of t into e raised to minus 2t into sin t of t. But the question didn't end here. They have asked us to find out the Fourier transform of d by dt of this signal, d by dt of t e raised to minus 2t sin t of t. So what property will you apply? D by dt of time differentiation property will give you j omega into x of j omega. I can write it as if x of t and x of omega are Fourier transform pairs, then d by dt of x of t will give you a Fourier transform. What is that? J omega into x of omega. Okay, j omega into x of j omega. You just multiply the frequency domain by j omega. That's all. Okay. So therefore I can write Fourier transform of d by dt of t e raised to minus 2t sin t u of t will be equal to multiply the RHS by j omega. That's what time differentiation property says. Okay, so j omega into j by 2 into minus 1 by 2 plus j into omega minus 1 whole square plus 1 by 2 plus j into omega plus 1 the whole square. We can write j into j is minus 1. That minus 1 can be multiplied inside. So the final answer will be omega by 2 into plus 1 by, because this product of j into j minus 1 is taking here, it will give you plus, and taking here, this term will be minus. So plus 1 by 2 plus j into omega minus 1 the whole square minus 1 by 2 plus j into omega plus 1 the whole square, and that is our final answer. Okay, let's jump on to the next question. A causal LTI system has an impulse response h of t equal to e raised to minus 4t u of t. Using Fourier transform, find the frequency response of the system and output of the system for a given input. So it is asked to find out the frequency response or whatever using Fourier transform. Okay, so you should not jump onto Laplace transform and all. Listen to the question carefully. Okay, so given the impulse response h of t equal to e raised to minus 4t u of t, and you have to find out the frequency response of the system. What do you mean by frequency response? And you are given impulse response. It is nothing but the Fourier transform of impulse response gives frequency response. Okay, I can write as frequency response is nothing but Fourier transform of impulse response. If I write it mathematically, it will be very clear. frequency response is h of j omega or h of omega, that is equal to nothing but Fourier transform of h of t. F of h of t is h of j omega. Okay, so just find out the Fourier transform of h of t, you will end up in the frequency response. Okay, therefore Fourier transform of h of t is equal to Fourier transform of h of t is given as e raised to minus 4t e of t, and we have the equation. This is equal to integral over minus infinity to plus infinity x of t into e raised to minus j omega t. Okay, x of t is e raised to minus 4t e of t into e raised to minus j omega t dt. That becomes, e raised to minus 4t is multiplied by u of t, so you don't have to integrate from minus infinity to infinity. The integral limits from 0 to infinity. Okay, so 0 to infinity, then now you don't need to write u of t any further because the limit has been truncated. So this is e raised to minus 4t into e raised to minus j omega t dt. That is equal to integral 0 to infinity e raised to minus of 4 plus j omega into t. I can write like e raised to minus of 4 plus j omega t dt. Now you just integrate it. That is equal to e raised to minus of 4 plus j omega into t divided by minus of 4 plus j omega under the limits, within the limits 0 to infinity. Okay, now you need to substitute the limits. Minus 1 by 4 plus j omega into, if you substitute the first limit, upper limit, e raised to minus infinity will be there. E raised to minus infinity will be is equal to 1 by e raised to infinity. That is 1 by infinity, that tends to 0. So the first term tends to 0 minus when you put the lower limit 0, e raised to 0 is 1. Okay, so this is minus of minus 1 by 4 plus j omega, that is equal to 1 by 4 plus j omega. So that is the answer to question number 1, frequency response of the system. Okay, answer to A. Alright. Alright, next you need to find out the output of the system for an input given as 3 e raised to minus t of t. Okay, so what you have in hand is the frequency response h of omega. So you know what h of omega is equal to y of omega by x of omega. How did you end up in this equation? It's a result from convolution property. Y of t is equal to, if it is an LTI system, it is given that it's an LTI system. Y of t equal to x of t convolution h of t. When you take the Fourier transform of this equation in both sides, you will end up in y of omega equal to x of omega into h of omega. From this, h of omega is equal to y of omega by x of omega. Okay, that implies y of omega is equal to, we have to find out the output of the system. Okay, so y of omega equal to h of omega into x of omega. Okay, that is h of omega we have already found out from the part A, 1 by 4 plus j omega into, what is x of omega? You have given x of t equal to 3 e raised to minus t e of t. So what is x of omega? It is straight away 3 by 1 plus j omega, right? Because the Fourier transform of e raised to minus at u of t is 1 by a plus j omega. Here is 1, so this is 3 by 1 plus j omega. Okay, now what is the next step? This is in the form of factors, so we have to make it a partial fraction and then find the inverse transform. Okay, how will you make it the partial fraction? This is equal to a by 4 plus j omega plus b by 1 plus j omega. You don't have to care whatever is in the numerator, just put a by the first factor in the denominator, that is 4 plus j omega here, plus b by the second factor in the denominator, that is 1 plus j omega. Okay, now find the LCM. So this becomes three is equal to a into 1 plus j omega plus b into 4 plus j omega. Okay. Now put j omega equal to minus 1. J omega equal to minus 1. So RHS, there is no change because there is no j omega term. 3 equal to a into 0 plus b into 3. Right? If you put j omega equal to minus 1 here, you will end up in 3b. So 3 equal to 3b. That will give you b equal to 1. Okay. Similarly, put j omega equal to minus 4. Again, LHS, there is no j omega term. So 3 equal to a into 1 minus j omega, 1 minus 4, right? J omega equal to minus 4 means 1 minus 4 is minus 3. Minus 3a plus 0b. That will give you a equal to minus 1. Okay, so we can rewrite our equation as y of omega is equal to a is minus 1. So minus 1 by 4 plus j omega plus 1 by 1 plus j omega because b is 1. Now it's only a matter of taking inverse transform, inverse Fourier transform. Inverse Fourier transform of y of omega is y of t. So y of t is equal to, what is the inverse transform of 1 by 4 plus j omega? You have this relation here, right? So 1 by 4 plus j omega will give you e raised to minus 4t of t. So minus, there's a minus sign already there. So minus e raised to minus 4t u of t plus, what is the inverse transform of 1 by 1 plus j omega? Again, it is in this format. 1 by 1 plus j omega will give you e raised to minus t u of t. So this is the final answer.